Hello and welcome to Science Talk with Jim Massa. I am your host, Jim Massa. In this video, I want to bring with you several stories involving some recent fossil finds. The first one I wish to start off with is a rather large creature. Basically, in a paper that's been published recently in the Journal of Vertebrate Paleontology, this paper describes a gigantic pterosaurian that is known only from its cervical vertebrae bones, which are neck bones. Okay. They haven't given this specimen a specific genus and species name yet, but they have assigned it to the family Arsdachidae, which includes the Quetzalcoatlus specimen, which was of course discovered in 1971, and Quetzalcoatlus had an estimated wingspan of 33 to 36 feet. Now, as I said before, it's only known from a few cervical vertebrae, but they use that to estimate the size. It's not perfect, but there are some indications that it could be as big as Quetzalcoatlus, perhaps bigger. If it does indeed turn out to be bigger than Quetzalcoatlus, then it might have been too big to fly. So you could have had your ancient version of a ostrich, a creature with wings but can't get off the ground. Why is this specimen, this find, so interesting and compelling? Very simply, it was found in Asia. Okay. Specimens of pterosaurs, which include pterodactyls as well, typically have come from North America and Europe. Now that we found specimens from Asia, this gives us a further geographical distribution of these types of creatures. Now, it's important to keep in mind that pterosaurs are not dinosaurs. They were reptiles. Okay. Yes, they lived at the same time as dinosaurs, but their physiology is different. They do, however, share the clade of Archaeopteryx. Now, what is a clade? I'll be making a video about clades and cladistic analysis and so forth. Basically, clade is a way of creating a tree, diagrammatic tree, showing the relationships of species to each other. And it is based on the concept of shared common features. So if we see two specimens that are closely placed on a diagram, which is called a cladogram, then those two species share a lot of common features, and they might have had recently branched off from a common ancestor. The fewer shared common traits, the further back in time is the split from whatever common ancestors those two species might have had in common. So, it is based on shared traits. The closer the more shared traits that are found in two species, the more recent is the split between those two species. Reduce that, and they go further back in time. If one were to go to the Museum of Natural History in New York City, they've redone a lot of the displays there, particularly involving the dinosaurs. And you see a skeleton there, what have you. And there will be a plaque that tells you what the skeleton represents, what species, what creature. And it gives a description of what is known about how this creature lived and so forth. And then next to that will be a little cladogram. And it will show you where that particular species, where it is in relationships to other species, closely related and not so closely related. It is a very good tool involving that. The next story involves what's called a little rainbow dinosaur. And this particular specimen was found by a farmer in China. Now the content of what I'm going to discuss here is a follow-up to an earlier report I did on pigmentation. So what would we have here? We have a Velociraptor-like skull. It's about the size of a duck. It's about 161 million years old. And it is noteworthy because they know it sported gleaming, iridescent feathers that were rainbow colored. And you may recall in my earlier video, I talked about how some of the feathers basically were found, and how they not just imprints, but they actually found fossilized feathers. So what gives the iridescent quality or aspect to the feathers? Well, inside the cells of the organism are found melanosomes, and melanosomes contain pigment. Okay? So Chad Eliason, he is a postdoctoral researcher at the Field Museum in Chicago, said that the preservation of this specimen was incredible, and they're seeing extremely excellent detail concerning the feathers. Where was the specimen found? It was found in the northeastern China province of Hebei, and it also had a unique bony crest on top of the head. The scientific name that has been assigned to this specimen is Keihongjuji, which is Mandarin for rainbow with the big crest. How were they able to ascertain that the dinosaur's feathers were iridescent and colorful? Well, they subjected the feathers under scanning electron microscope, SEM. And by looking at the shape of the melanosomes, they can infer the coloration that would be imparted. Based on different shapes, the melanosomes will reflect light in different manners. As an example, if we take hummingbirds, now we know hummingbirds are very iridescent, very colorful feathers, and so forth. But if you were to take the feathers of a hummingbird and mash it down, you're just going to have a pile of black dust. What you then do is you look at the shape of the melanosomes, and then from there you can say, oh, this shape will reflect this wavelength of the electromagnetic spectrum, giving this color, and so forth. Well, here's the interesting aspect. They found pancake-shaped melanosomes in C. juji, which match those of hummingbirds. So, we have pancake-shaped melanosomes in hummingbirds. We know that those shaped melanosomes gives this color. We see the exact same shape in this new specimen, so it must have those colors. Very interesting here. Now, C. juji isn't the first dinosaur on record to have iridescent feathers. Microraptor, a quote-unquote four-winged dinosaur, also sported gleaming feathers. Basically, there were feathers on all its limbs. Microraptor, however, lived 40 million years after C. juji. So C. juji is now the oldest dinosaur on record to have iridescent plumage. It is also the oldest animal on record to have asymmetrical feathers. Now, asymmetrical feathers helps with flight, helps with steering. Okay? However, in modern birds, the asymmetrical feathers are on the wingtips. C. juji spotted the asymmetrical feathers on its tail. Did it have flight? There's indications it might have had some limited flight capabilities, but certainly not sustained flight capabilities as in present modern day birds. It would most likely have used its feathers to attract mates and for insulatory purposes. However, co-researcher Zheng Zhu, who is a researcher at the Institute of Vertebrate Paleontology and Paleoanthropology at the Chinese Academy of Sciences, he does suggest that these particular feathers may have played a role in early controlled flight. So in essence, what we're seeing here is we're seeing kind of a transition. We're seeing a mixture of what might be called old traits with some new traits that are evolving. The report can be found in the Journal of Nature Communications. The next story I'd like to share with you involving dinosaurs / avian forms is one that comes out of Germany. Scientists in Bavaria have identified a new fossil of possibly the oldest known specimen of Archaeopteryx. Archaeopteryx was once thought to be the feathered link between dinosaurs and modern birds. However, we now know, thanks to many specimens that have been uncovered in recent years, that theropod dinosaurs were covered in feathers or sported feathers of some sort. Now, theropod dinosaurs include T-Rex, Velociraptor, Allosaurs, and other two-legged, basically meat-eating critters. Or as Dr. Robert Bacher famously described T-Rex as the 40-ton roadrunner from hell. Anyway, the sites in southern Germany where these particular fossils were found were once, and this is really interesting, were once islands in a chain known as the Jurassic Sonhofen Archipelago. This is important as this indicates geographical isolation, which allows for a faster pace of evolution. This is basically an ancient analogy to Darwin's finches, right? The Galapagos Islands. We had geographical isolation, and those finches evolved different beaks and to utilize different available food and exploit different niches. This is very similar to Darwin's finches, and it's really, really fascinating because Archaeopteryx was not just one single species, but several species. Okay? So Archaeopteryx was just one of many bird-like dinosaurs. Note the phrasing, bird-like dinosaurs. It's still considered a dinosaur with bird-like features. There are other such bird-like dinosaurs, for example, Archaeornithera and Confuciusornis. Okay. So the gentleman who led this study is a gentleman by the name of Oliver Rohut of the Bavarian State Collection for Paleontology and Geology located in Munich. Okay. The specimen that was found is approximately 150 million years old. And as I noted before, and Professor Rohut basically says that this is a Jurassic analogy or analog of Darwin's finches, where we have an island archipelago, geographical isolation, increasing the pace of evolution. Now, scientists, this is important. This is often one of the, how do we date the specimen? Well, sure, we have radioactive dating. We can look at the strata of the rock formation. Scientists will sometimes also use extinct mollusks called ammonites. Ammonites are basically sort of like a chambered nautilus straightened out. But based on the ammonites found near the specimen here, this is how they determine that this is about 152, 151 million years ago. This might make it the oldest of the 12 fossils that have been classified as Archaeopteryx. In other words, there might be up to 12 different species of Archaeopteryx. Specimens of Archaeopteryx are now known from 3 distinct rock units, which cover a period of approximately 1 million years. Professor Rohut also stated. He is also an associated professor at Ludwig Maximilian University in Munich, so he kind of holds a couple of hats here. He added that these specimens show a great deal of diversity in their physical characteristics, which is further evidence that the fossils could represent more than one species. What is particularly striking, and think back to Darwin's finches, is the high degree of variation in the teeth. The arrangement of the teeth is different in every specimen, and this could possibly reflect differences in diet. His work, his study, can be found in the journal Peer. At this point, I wish to remind you that my work can be found at patreon.com/Science Talk with Jim Massa, each of the words separated by an underscore. If you are already a subscriber and a patron, I thank you for your support. I ask you to inform others of the work that's done here and where to find my work. If you are not viewing this on Patreon, I do post additional materials that can only be found on Patreon, basically as a bonus to my subscribers. Thank you for your support. Please tell others of my work.